Hello students, welcome to Swapna physics classes. In this lecture I am going to explain you one more important short answer question for your TS intermediate second year IPE physics examination. And the question is, with a neat labeled diagram, explain the formation of the image in a simple microscope. What is a simple microscope? It is a converging lens. It is a converging convex lens. The lens here we are using is a convex lens, which is having small focal length, and is also known as a magnifier. Okay, what is a magnifier? Whenever you observe a small object, very small objects like microbes, okay, if you use a converging convex lens, what happens? These microbes will be enlarged in size. Okay, if you want to observe the microbes or very small organisms, then this converging convex lens will be used for observing these microbes or microorganisms. It enlarges the size of the object. Okay, and how to use this microscope? The lens is placed very close to the eye, right? Examples: spectacles. Okay, for example, you might observe that whenever your father or your grandfather reading the newspaper, the spectacles contains a convex lens at the bottom of the lens, right? This lens is used for enlarging the size of the letters in a newspaper, right? This is one of the example. And the image will be formed at a distance of 25 centimeters, and the image is erect, magnified, and is a virtual image. What is a virtual image? The image which is formed on the same side of the object. For example, here I have a double convex lens. Assume that this is a double convex lens. What is a convex lens? Which is bulged outward. Here I have taken double convex lens. And if this is the principal axis, axis of this lens, and this is the center, optic center of the lens, and this is focus points of each lens. Here we have two lenses, convex lenses, therefore we have two focus points. Okay, and what is virtual image? I am going to explain, right? If this is the object and the image will be formed in the same side, the image also formed in the same side. Okay, this is the object, this is the image. If the image is formed on the same side of the object placed to the lens, this type of images is known as virtual images. Okay, if the image is formed on another side of the lens, then those images are known as real images. Here the image formed is erect. Not inverted. Image is erect. It is a virtual image and is magnified. Magnified means it is enlarged comparing to this object. Okay, now using a microscope, the image will be formed at near point and also at a far point. At far point means infinity. At near point means less than infinity. Okay, and where we have to place the object to form the image, at the near point or at a far point. Let us see. Formation of the image. Formation of the image at near point. At near point. Okay. Here I have a convex lens, double convex lens, and if this is the principal axis. This is the principal axis for this lens, and this is the optic center. And here we have two focus points. Here we have two focus points because here we have taken a double convex lens. Here we have taken a double convex lens. And I am taking the object A, B in between the focus and the center of the lens. Then this is the ray diagram. Okay. I am choosing two rays. For observing the formation of the image. I am taking a ray which is parallel to this principal axis. I am considering a ray from the tip of the object which is parallel to this principal axis, and this ray get refracted. This ray gets refracted and passes through the focus. And I am taking one more ray which is passing through the center of the optic center of this lens. Okay, and this ray will move in a straight line. If you extend these rays in backward direction, if you extend these rays in another direction, these rays will meet at some point. And at this point the image will be formed. I. Okay. You just observe this image. This image is enlarged one comparing to this object. Okay. It is erect and it is a virtual image. And the image formed is less than infinity. The image will be formed at less than infinity. The image is formed in between object. Image will be formed in between object and infinity. Okay, and the distance between the image and this optic center is approximately equal to 25 centimeters. This causes the strain in our eyes. Okay, and the image formed at infinity. And the object is placed at the focus point. If this is the double convex lens, keep the heading image formed at infinity. Or far point. Okay, and this is the principal axis of this double convex lens, and here we have two focus points. The object is placed at one of the focus points, right? And I am choosing two rays from the tip of this object. Okay, one of the ray which is parallel to this principal axis, and the other ray is passing through the optic center. The ray which is parallel to the principal axis, after refraction, will pass through this focus, and the ray which is passing through the optic center after refraction will move in a straight line. The ray will pass through this optic center only, and these rays are approximately parallel to each other. And if you extend the rays in another side, what happens? These rays are parallel to each other. These rays will be parallel to each other. That means they will meet at some point which is at infinity. The parallel rays will meet at infinity. That means the image will be formed at infinity. The image will be formed at infinity. Okay, and we can view this image relaxedly. Okay, there is no strain causes in our eyes. We can view relaxedly. Okay, here is the observer, and for this here will be the observer. The image formed will be erect and is magnified, and it is a virtual image. It is a virtual image. This is the formation of the image using a simple microscope. Here I will end our lecture, and whoever didn't subscribe to my channel, please click on subscribe button and also click on like button, and share with maximum number of people. Share with maximum number of people possible. Okay, bye.